The second major way the ACT likes to ask algebra function questions is composition of functions. Just like I promised in the first video and in the material, these are still plug-in problems. They just become multi-step. So let's talk about notation first. In the problem below, we have G circle f of x, which is a valid way to say it. You could also say G composed with f of x. I like saying G of f of x. It's probably what you've heard most. It doesn't matter. It doesn't matter at all. Remember, we only care about what works and what's fast, not math convention. So the important thing about this is that this is used sum, right? You see this sum on the ACT. It's one of the reasons I picked a problem with it, just because I could expose you to it a little bit more that way. But it's the exact same thing as G of f of x with the parentheses, which is what you're probably most accustomed to. This is the same. And if you look at it, it's going to work the same. The innermost function, the one we'll do first, is closest to the x. The outermost function, we'll use that output as the input. And if that's mystifying to you, let's clear that up. Remember, this is our placeholder. It's our placeholder for our, in this case, it's usually just the input. In this case, it's our first input. And if you're a little unclear on that, check out the first video on algebraic functions and check out the material in the book. I go over that in detail. This first input goes into function f, right? Goes into function f as the input. F will spit out an answer, right? F will spit out an output. An output will come out of here, the f of x value, the y value for f of x. That output is the input, is the second input for function g. Now, G and F are the most commonly used letters when we talk about functions. They could be any letters. And it doesn't have to be G of f of x. It could be f of g of x or whatever. I'm just using that because it's very common. Just, if you see an F, it doesn't mean F goes first. If you see a G, it doesn't mean G goes last. What's on the outside goes last. What's on the inside goes first. It's like this. Here's your initial input, your x, right? That pops out to an output with f of x or whatever you got your inside function as. Then that becomes the input to your outside function, your g of x in this case, which will give you your final answer. So start, boom, boom, kind of expand. All right, let's take a look at the problem. I'm going to go ahead and write this up here. So we have f of x equals 2x squared minus 2. G of x is equal to square root of x plus 3. And I'm just going to erase this right side here because the notation is appropriate on the left, except I'm going to take that x out, put in a negative 2. Okay. And I want to know what that equals. Negative 2 is my first input. That goes into function f. So I'm going to drop this down here. And let's move g of x over for right now so I can work this. Negative 2. So just like in the last video, just like any other function problem plug in, this goes wherever x is. And the same things, operations-wise, that happen to x happen to the negative 2. So you run through your order of operations. The exponent goes first. Negative 2 squared is 4. Still multiplied by 2. Subtract 2. So 2 times 4 is 8 minus 2. F of x is equal to 6. Excuse me, f of negative 2 is equal to 6. Now, take a look at the g of x. G of x will work like this. So g of x, if you recall, was square root of x plus 3. Okay? So my output here is 6. That's the input for g. So g of 6 is, remember, just stick it wherever that x is. Same stuff happens to the 6 as happens to the x. Square root of 6 plus 3. square root of 9. So g of 6 is equal to square root of 9 is equal to 3. Could also be equal to negative 3. 3 is the only answer that's given in the answer choices. So that's it. There's not a ton to it. You just have to work it in a couple steps. Inside out, if you just go bump, 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 you'll get these right every time. Doesn't matter if they have variables involved in the inputs, it doesn't matter. You can still do it. It's just one piece at a time. These are good points to get. Both the regular function problems and these composition function problems. They mainly operate by intimidating you. Don't let these problems intimidate you. Learn the secret that they're plug-in problems. Learn a couple of the mechanics of how they work. Cover more of that in the book, and you'll do great on it.